Okay, today we're going to go over the CC1 9.2.2 sixth grade homework. In a bicycle race, I guess we're starting with problem 44. I got ahead of myself a little bit. In a bicycle race, bicyclists rode 82 miles on the first day. The 82 miles represented 20% of the entire race. Okay, so how long was the entire race? Write an equation and then use it to find your answer. Remember to define your variable. Okay, so I'm trying to figure out the entire bicycle race. So I'm going to let R equal the entire race. Okay, so I'm trying to figure out R. So I'm going to, I know that 82 miles on the first day is 20% of the whole race. Okay, so I'm going to actually cross this off. I'm going to explain this a little bit differently. Okay, so I have the whole race. Okay, 20% of the whole race, that's multiplication, is going to give me the distance that I rode the first day. Okay, distance for the first day. I'm not going to use a variable in this instance because I know how much he rode on the first day. So 20% of the whole race is 82 miles. How am I going to figure out what R equals? Well, R equals 82 divided by my 20%. Okay, if I put that into 82 divided by 2 is 41. And I had to move my decimal over, so it's 410. So it's 410 miles. Okay, if I do that longhand, this is what it looks like. Just to practice division skills, we move my decimal, 2 goes into 8 4 times. Bring down my 2. 2 goes into 2 1 time, just 2, and 2 goes into 0 0 times. That's how I got that 410. Okay, so the whole race is 410 miles. Okay, part B. If bicyclists rode 21% of the race on the second day, how many miles did they ride on the second day? Okay, I have 21% of my race. I know what my race is now. It's of 410 miles equals, and I'm going to let M equal the miles on the second day equals M. Okay, this is a multiplication problem. 21% times 410 equals, so 410 times 21%. 1 times 0 is 0, 1 times 1 is 1, 1 times 4 is 4, 2 times 0, 2 times 1, 2 times 4 is 8. I can add them together. One plus 0 is 1, 4 plus 2 is 6, 8 plus nothing is 8. I move my decimal 2 places. Okay, so on the second day, they ride 86 1/10 miles. Part C, after completing the first 2 days as described, the bicyclists have what percentage of the race left to ride? Okay, first of all, I have to think about it. Okay, in day 1, they completed 20%. In day 2, they completed 21%. Added together, they have completed 41%. Of the whole race. The whole race is 100%. So uncompleted, they have it's 100% minus 41%, which is 59% of the race. Part D, how many miles do the bicyclists have left to ride? I can do this 2 ways. First way. Okay, I'm going to do it both ways so you can see both ways. The first way is I can say, well, they have 59% of the race to finish. So 59% of the whole race, which is 410 miles. That's a multiplication problem. 59% is 0 and 59 hundredths times 410. Okay. When I put that into my calculator, I'm going to get 241 and 9/10 miles. Okay. So that's the first way I can solve it. Another way I can solve it is to say, okay, they went 82 miles. They also went 86 and 1/10 mile. You can add those together. 6 plus 2 is 8. 8 plus 8 is 16. They went 168 and 1/10 of a mile. Well, the whole race is 410 miles. If I take away what they've already done, okay, now I'm going to kind of mess myself up by writing the miles there. I'm going to rewrite it. I have 410 minus 168 and 1/10. I want to line up my decimal place. I did fill in, especially when I'm subtracting. I have to borrow from my tens place and then borrow from my ones place. So then I can do 10 minus 1, which is 9. 9 minus 8 is 1. I have to borrow from my hundreds. 10 minus 6 is 4, and 3 minus 1 is 2. I get the same answer. Okay. Problem 45. If Miss Westhagen can knit 5 hats in 19 hours, this is her rate of knitting, how long is it going to take her to knit 12 hats? So eventually I want to figure out, well, how many hours for 12 hats? Okay. So one of the things that I like to do, 5 doesn't go into 12 evenly. So I could use division and do it and find a decimal that I'm multiplying by. Or I can say, okay, 1 goes into 12 evenly. So how much time did it take her to do 1 hat? So I did 5 divided by 5. If I do it to the top, I have to do it to the bottom, numerator, denominator. 19 divided by 5 is 3 8/10. It takes her 3 8/10 of an hour to knit 1 hat. Now I can say to multiply 1 times 12 to get to 12. 3 8/10 times 12. 2 times 8 is 16. 3 times 2 is 6 plus 1 is 17. Or 7, not 17. Sorry. Drop my 0 for place value. 1 times 8 is 8. 1 times 3 is 3. I add 6 plus 0 is 6. 7 plus 8 is 15. 3 plus 1 is 4. I put in 1 decimal, so 1 place value over. It takes her 45 6/10 hours to knit 12 hats. On the back side, we have problem 46 says to plot the following pairs of points on a 4-quadrant coordinate graph, then find the length of each segment. Okay, so I'm going to start with -2, -4. So -2, -4. So 1, 2, 3, 4. That's here. Okay. -2, +8. 1, 2, 3, 4, 5, 6, 7, 8. And I want to figure out how far apart they are. I could count. Okay. But I'm going to focus on working with absolute value to find the distance between 2 points. So I've plotted it. We know how to plot it. I can count. We know how to count. But this is something we haven't done in a while. So when I look at remember my X's and my Y's. If I look at my X's and my Y's for these 2 points, my Y's are the ones that are different. Okay, those are the ones that I'm going to put inside of my absolute value sign. And I subtract them. It does not matter the order that we put them into the absolute value. -4 -8, I'm going to keep going to the left. So it is -12. The absolute value of -12 is 12. The length is 12 units. Part B. I have 3, 5. So 3, 1, 2, 3, 4, 5. And -8, 5. 1, 2, 3, 4, 5. I'm going to draw the line so that I know which 2 that I'm looking at. That is for part B. I could count again. Not impossible to count, but again, I want to work with that absolute value. So I look at my 2 X's and my 2 Y's and say which ones are different. In this case, it's the Y's. That's actually what tells me that it's going to be horizontal instead of vertical too. So I have 3 and -8. I'm going to show you guys that it does not matter which one I put in first. So I have -8 and 3. I subtract them. I'm going to do the same problem over here, but I'm going to do 3, -8, and then subtract them. Okay. Starting with what I started with originally, -8 - 3. I'm going to keep going negative. -8 - 3. I'm going to get -11. The absolute value of -11 is 11. Now, if I go to this other one that I set up, putting the first coordinate point in first, 3 minus -8. These 2 negatives are right next to each other. That forces them to, it's the opposite of the opposite, which we know is a positive. 3 plus 8 is 11. The absolute value of 11 equals 11. It's 11 units. Sometimes if I'm trying to decide what numbers to put in first, I want to try to think about a way that I can make it more efficient for myself. If I have a hard time remembering that the 2 opposites make a positive, then I'm probably going to use this other version. Okay. I'm going to make it efficient, as efficient as possible for myself. So part C, 2.5. So 2.5 is here. -3 is here. 5 1/10. I'm going to kind of guess it's going to be really close to the line that's 5, and it goes down to the 3. This is one of those, I can't count this, okay? So the absolute value does come in handy here. I am gonna start with the 5 1/10 that's different, and the 2.5, and I'm gonna subtract it. See how that's more efficient for me than saying 2.5 minus 5 1/10? Because I can set this up into a problem that I already know how to solve. To borrow from my ones place, 11 minus 5 is 6, 4 minus 2 is 2. The length is 2 6/10 units. Last but not least, part D, for negative 4 3/10. So that's going to be just past the 4, between the negative 4 and the negative 5. And it went up 2. And then we did negative 4 3/10 and up to 6 3/10. So that was 2, 3, 4, 5, 6, and a little higher. Again, I am going to make this more efficient. It is easier for me to say it's 6 3/10 minus 2/10. It's an absolute value sign, not a parenthesis. 6 3/10 minus, oh, I'm sorry, it's not 2/10, it's 2. I apologize. 6 3/10 minus 2. 3 minus 0 is 3. 6 minus 2 is 4. Bring down my decimal. It's 4 3/10 units. Okay. Problem number 47. Find the area and perimeter of each shape. Show your work. I'm going to start with my perimeter, only because I can easily just go around the outside. So I have, I'm going to write it to the side over here. I have 7 2800ths plus 10 plus 7 plus 10 plus 2. I can fill in and line up all my decimals. 8 plus 0 is 8. 2 plus 0 is 2. 7 plus 0 plus 7 is 14. Plus 0 is 14. Plus 2 is 16. 1 plus 1 plus 1 is 36. My perimeter is 36 2800ths inches. For my area, as a reminder, my area formula for a trapezoid is base 1 plus base 2. So add the bases, times the height, divide the whole thing by 2. So one of my bases is 10. I added 12. And I multiply that. My height is not this. This is not my height. My height is 7. It's the one that's perpendicular, and I divide the whole thing by 2. 10 plus 12 is what I do first. It's 22. I multiply that by 7, divide by 2. 22 times 7. 7 times 2 is 14. 7 times 2 is 14 plus 1 is 15. It's 154. Divided by 2. 154 divided by 2. 2 goes into 1 0 times, but 2 goes into 15 7. Leaves 1 left over. I drop down my 4. 2 goes into 14 7 times. Don't have any remainders, so it is 77, which is my area. It is 77 inches squared. For my triangle, again, I'm going to start with my perimeter. I have 10 plus 13 plus 13. It's 10 plus 26. 10 plus 26 equals 36. It's 36 meters. Remember, the area formula for a triangle is base times height divided by 2. My base is 10. My height is 12. divided by 2. 10 times 12 is 120, divided by 2, which is 60. The area is 60 meters squared. Our last problem is to write each of the following as percent, fraction, decimal, and with words. Remember, our words go along with our decimals. To go from a percent to a decimal, I have to move my decimal 2 places. So I go to the left, so 1, 2. My decimal is going to be 0 and 875 thousandths. The 5 is in the thousandths place value, so my fraction can be out of 1,000. It's 875 out of 1,000. Again, I can put a decimal. I don't like to. Okay. I like to look at the place value and say, okay, it's in the thousandths place. With words, 875 thousandths. I could write 0 and 875 thousandths, 0 and 8 tenths, 7 hundredths, 5 thousandths. It's up to you. This is one of the easier ways to write this one. More efficient, not easier. To go from a decimal to a percent, if I went back to the left, I divided by 100 to get the decimal. I multiply by 100 to get the percent. It is 33%. Percents are fractions out of 100. In words, 33 hundredths. Or I could write 3 tenths and 3 hundredths. As always, if you have any questions, please make sure you come and talk to me.